Okay, student, this is our second lectures of ODL lecture series, and this is about the advanced oxidation processes. These are very important processes in wastewater treatment and modern day treatment technologies. We usually use combination of technologies to treat the wastewater, and among them, advanced oxidation processes. They are one of the options in future. As far as the definition is concerned, the AOPs, they are the processes that involves the formation of hydroxyl radicals in sufficient amount so that they can affect the water purification. So any process by which you would be able to generate hydroxyl radicals in water or wastewater in sufficient quantity so that it can affect the water purification, that process will be known as advanced oxidation process. So there could be many ways: by ozonation, by UV based processes, by Fenton type, photofenton type processes, by wet air oxidation, or there could be many processes by which we can generate hydroxyl radicals. So such processes that involves the generation of hydroxyl radicals, they are known as advanced oxidation processes. Here are some examples like Fenton process, photofenton processes, catalytic ozonation process, and sonolysis. Now the question is why we need AOPs, why we need hydroxyl radical based processes. Since the new challenges, the pollution, it's not uh, it's quite simple now. We can say it's quite complex due to the new challenges, development, urbanization, and industrialization. The new chemicals they are being released to the environment. Some are highly resistant and very strong chemicals, persistent nature like pesticides, personal care products, endocrine disrupting chemicals, pharmaceuticals that are very difficult to degrade by conventional biological processes. Some of them they are anti bacteria, for example, antibiotics. So they are very difficult to treat. That's why there is a need that we should develop such processes that can even uh, helpful in the degradation or in the reduction of pollution uh, that use of some advanced methods. So इसी तरह से हाइड्रोक्सिल रेडिकल बेस प्रोसेस को दिया गया हाइड्रोक्सिल रेडिकल्स ही क्यों बेस ये एक बहुत ही स्ट्रॉन्गेस्ट ऑक्सीडेंट दे आर अमंग द स्ट्रॉन्गेस्ट ऑक्सीडेंट one of the strongest oxidant or almost second strongest oxidant जो है they are the hydroxyl radicals, so they can quickly degrade the pollutants because they are highly reactive and non-selective, and they can degrade several pollutants. Any pollutant that come in their way they can degrade them. They are non-selective in nature. So I used to usually say okay, hydroxyl radicals are blind. Any organic pollutant come in their way, they would try to stabilize themselves because hydroxyl radicals have a single electron. They are highly unstable, so they want to stabilize themselves. They can add to some organic molecule, they can take an electron from some organic molecule, so they just want to react so that to stabilize themselves. That's why they are highly reactive and they are non-selective. Some of the species they are selective in nature. They select a particular functional group. For example, some of them like ozone, it selects double bonds or triple bonds, unsaturated species. But hydroxyl radicals they are non-selective in nature. So in this slide, I'm going to show you the different properties of hydroxyl radicals so that we will be able to know the importance of advanced oxidation processes because they are based on hydroxyl radicals generation. The one thing is, if you look at the table on your left side, so after fluorine, the second strongest oxidant, they are the hydroxyl radicals. So they have the second highest oxidation potential among the oxidant species, even higher than the nascent oxygen, ozone, hydrogen peroxide, per, perhydroxy radical, hypochlorous acid, and chlorine. So they are at the second of that list. So they are highly selective. Sorry, they are non-selective. I told you before. Highly reactive, easily generated, powerful oxidant, short-lived, and they can control the reaction rates, and they are harmless in nature. So due to these properties, uh, they are they may be quite useful in future technologies for the treatment of water and wastewater in combination with other processes. As told you before, why we need AOPs, because these processes, they are highly effective, and there are many resistant organic pollutants these days. They've been found in water and wastewater. So for example, antibiotics, pesticides, endocrine disrupting chemicals, etc. So they are highly resistant to biological treatment. Therefore, the advanced oxidation processes, they are the need of hour. They are required nowadays, since they are a bit expensive. So it is recommended to use them as a combination of techniques. We can use them in combination with conventional biological processes. Now, there are various methods by which the hydrogen hydroxyl radicals they can be generated, और इनके मेथड ऑफ प्रोडक्शन की बेस पे हम इनको क्लासिफाई कर सकते हैं डिफरेंट टाइप्स में. among them ultrasound, electrochemical process, chemical process and photochemical process. स्टूडेंट ये जो आप टेबल देख रहे हैं इसमें डिफरेंट प्रोसेसेस को बताया गया है, उनकी क्लास को. फोटोकेमिकल है, केमिकल, अल्ट्रासाउंड और इलेक्ट्रोकेमिकल प्रोसेस. एंड देन वी फर्दर, in order to understand, it was further characterized production of hydroxyl radicals from ozone or per ozone based reactions, means in which the ozone and hydrogen peroxide they involved in the production of hydroxyl radicals. So ozone based reactions in which only the ozone is involved, and per ozone based in which ozone and hydroxyl radicals they are being involved, and then the direct energy transfer based reactions in which the direct energy is involved to produce the hydroxyl radicals, then Fenton homogeneous or heterogeneous process and heterogeneous catalytic processes. So let's see the photochemical process. Photochemical means from its name in which the light is involved. So उसकी example क्या है? ओजोन यूवी बेस्ड प्रोसेस भी हो सकता है. ओजोन यूवी के प्रेजेंस में हाइड्रोक्सिल रेडिकल्स में प्रमोट करती है फॉर्मेशन ऑफ हाइड्रोक्सिल रेडिकल्स. एंड देन केमिकल प्रोसेस की भी इस तरह एग्जांपल्स हैं. ओजोन at basic pH in the presence of hydroxide ion, it reacts with the hydroxide ions and generates hydroxyl radicals. इसी तरह से अल्ट्रासाउंड में ओजोनेशन and ultrasound can promote generation of hydroxyl radicals. इसी तरह ultrasound per ozone based reactions in which ultrasound and hydrogen peroxide and ozone they are being used. Then sonolysis, the type of direct exposure of ultrasound radiations to generate the hydroxyl radicals from the water. And then Fenton or Fenton like processes. Fenton process is the one in which we use the Fenton reagents, that's the ferrous sulfate and hydrogen peroxide. So there could be Fenton type and Fenton like reactions in which iron based species may be coated, heterogeneous process हो सकते हैं, और homogeneous in which in heterogeneous Fenton type processes iron is may be coated on some surface like activated carbon पे coat किया हुआ है, peanut shell पे, ash पे, rice husk ash, and there are many other examples. Iron की form +2 use की है, ferric or ferrous form can also be used in these processes. The purpose is to generate the hydroxyl radicals. So, and finally, the heterogeneous catalytic processes, they also different types that can promote the generation of hydroxyl radicals. Photochemical भी हो सकते हैं, chemical भी हो सकते हैं, ultrasound भी, और electrochemical heterogeneous catalytic processes भी हो सकते हैं. Now, on the basis of the phase type, we can divide the AOPs into two classes, two types: homogeneous processes and heterogeneous process. Homo means same, hetero means different. So in which the same phase, uh, catalyst and the pollutant, if they are present in the same phase, it's called the homogeneous process. और जिसमें different phase में हो, it's called the heterogeneous process. For example, अगर हम iron sulfate use करते हैं as a catalyst in water, so iron will get dissolved into the water, so it will be in aqueous phase. So iron will interact with hydrogen peroxide in aqueous phase, so it's called the homogeneous process. So on the other hand, if we coat the iron, impregnate it on some solid sport, for example, if we impregnate it on the uh, rice husk ash, so rice husk ash is a solid material, so the catalyst would be in the solid form, in liquid, and it will interact hydrogen peroxide which come from the liquid form and interacts on the surface of the solid and interact with the coated iron sites on the surface of the solid. So there are here different examples of homogeneous AOPs and heterogeneous AOP processes. For example, photochemical and chemical based key examples हैं. Among the photochemicals, UV photolysis, phantom process, UV ozone based process, UV hydrogen peroxide based process, UV ozone hydrogen peroxide based process, etc. And similarly from heterogeneous process में photochemical की example अगर हम देखें तो UV ozone and solid catalyst titanium, and there could be some other catalysts like UV hydrogen peroxide, activated carbons. They can be used as catalyst in some processes. Iron loaded activated carbons, fly ash can be used as a catalyst. Here I'm going to give you a simple example of a simplest mechanism of AOPs. The mechanism is, there are many mechanisms that have been proposed. It depends on the catalyst, type of the pollutant, catalyst, how it's involved, what kind of a byproducts formed, and the nature of the process. So there could be many mechanisms. They have been proposed. ठीक है, जो कि इन फैक्टर्स पे डिपेंड करते हैं, which I had told you before. तो simple जो mechanism है, in order to understand how the AOPs they works, so a pollutant in the presence of this kind of example, it's about the photolytic process, photocatalytic process की example दी है. In the presence of UV light, for example, not necessary every in all AOPs UV is involved, ठीक? So the catalyst, it uh, react with the ozone or hydrogen peroxide and generates hydroxyl radicals, and the pollutant, it will be degraded by the hydroxyl radicals, and finally it mineralizes to water and carbon dioxide. So in this slide there are some examples of generalized free radical reactions. And the free radical have, because it has one electron, it needs an electron, another electron to balance. So ये quickly react करता है कोई और species से. Either it can take an electron and उसको radical बना देता है, maybe an organic compound comes in its way, कोई pollutant आता है तो it takes quickly an electron from it. ठीक है, इसी तरह से एक chain reaction शुरू होता है. और it can also combine with a radical species and add to a species having a free electron with it, so it can react to it and form a stabilized form. Student, these are some examples of advanced oxidation processes. The first, ozone peroxide process. And the ozone peroxide AOP process is the one in which ozone and hydrogen peroxide, they both are used together to generate hydroxyl radicals. So in such a process, hydrogen peroxide reacts with the water molecules and form hydronium ion and HO2 ion. So this, or hydroxy ion, it reacts with the ozone to generate the hydroxyl radicals. This is another example of AOPs. It's an example of UV ozone based process. Ozone in water, when it's been bubbled into the water in the presence of UV light. So what happens? UV light provides energy to break down the ozone. So two hydroxyl radicals, they've been formed along with the oxygen molecule, and these hydroxyl radicals then they can react with the pollutant uh, to degrade them.